Hey, it's Friday. Good morning to you. Welcome to another edition of the Weather Academy. I'm meteorologist Tom DeVecchio with meteorologist Craig Flint.
Hey.
Once again, now we're going to go off the beaten path just a little bit and talk about something that is really kind of cool.
It is awesome. It's probably one of my favorite things next to lake effect.
Yeah, there you go.
Some of the stuff that happens in the sky, we have aurora borealis, which is northern lights, which does happen in the southern hemisphere too. It has to do with poles and the magnet in the earth and all that stuff. Did you know that? There's a big, almost like a magnet in the center of the earth.
Yeah, there is.
Causes all kinds of colors.
And if you look at, there's a magnetic field here that the Earth makes, just like your little magnets that you may have learned in school.
Yeah,
the
pretty
Earth
cool
is one big magnet.
So we're going to talk about rainbows and sky optics today, because there's a lot of things that happen in the sky that if you happen to catch one of them, you look up and go, what is going on there? So we're going to kind of delve into this topic a little bit more, and it's all about your eyes and what we call the visible light spectrum. Your eyes are trained to see certain colors on a spectrum or wavelength, and those colors appear different to your eyeballs. So some pretty interesting facts coming up.
Absolutely, and it's part of what we call the electromagnetic spectrum, and this includes X-rays. X-rays for your bones. That's all part of it. X-rays, infrared rays, the ultraviolet rays that give us a tan and give us a burn when we have too much. And the visible spectrum that Craig is talking about is actually a very tiny part of the whole spectrum, and yet it's by far the biggest part of our lives.
Yeah, and we use color all the time in meteorology. When we look at, Tom mentioned infrared imageries, which basically the satellites that we use now are equipped with temperature sensors, and they can measure the temperature of the clouds at different levels, which really helps us to determine cloud cover. But kind of getting back on track here, everyone's seen a rainbow, like the picture there behind us. And if you look close enough in that picture, there's actually a double rainbow. Now, the basics of the rainbow: Roy G. Biv. Roy G. Biv. Red, orange, yellow, green, indigo, violet.
Right.
I forgot blue in there.
Blue. Don't forget blue. Yeah.
But anyway, so everyone's seen that. So that's kind of example of a rainbow. So let's delve into this a little bit more. And well, for rainbows, obviously you need the sun and the rain to make this work. And there's little Tommy DeVecchio right there. What are you listening to back in the day?
Oh boy. I don't know if you'd want to know. Yes. Probably something, maybe the Doobie Brothers or Boston or Chicago back then. Yes, kids. Yes, they're cities, but they're also musical groups.
So basically, in order to see a rainbow, you have to be in between the sun and a rain shower, with your back towards the sun and looking towards a distant rain shower. So basically what happens is the sun shines into a raindrop. You can see the sun there, and then the arrow's going into the raindrop. And what happens when it gets into that raindrop, Tom?
Well, as it goes in, raindrops, light, the rays of light, I know we can't see them. We can't see the rays. Obviously, we can see the light itself, but we can't see the rays. But they act a lot, almost like a string or a piece of metal, and it can be bent. You can bend them. So when light goes into a raindrop, it enters the raindrop and it bends. We call that refraction. It changes direction. And then what happens if, Cindy, why don't you come back to us here real quick here. And if you look here, it goes into the raindrop here and bends. Then it hits the back end of the raindrop and it reflects like a mirror. In that reflection, the sunlight, which is composed, as Craig mentioned, all the colors of the rainbow, it splits those colors into its individual parts. So by the time it comes out and it reaches your eyes, you see that as color.
Yeah, so pretty cool. It kind of bounces off the raindrop and it will reflect back to your eyes as the colors of the rainbow, with red always being the uppermost color. So that's kind of the quick and dirty explanation, if you will. The sunlight passes or goes into the raindrop, bounces back to your eyes, and that's when you get that Roy G. Biv color, the rainbow color. And little Tom the Vector.
That's right, yes. And then what happens now, Craig showed you earlier picture, it was a double rainbow. Sometimes what can happen, especially if you get a lot of moisture in the air, the process happens twice.
Yeah, it can reflect twice.
So that the reflection goes back and the process starts a second time from the original rainbow. The light from the original rainbow gets refracted by the raindrops and reflected again, so you get a double rainbow. Now, because the rainbow light is a lot dimmer than sunlight, the secondary rainbow is always dimmer, a lot dimmer sometimes. But you also find that the colors reverse.
It's a mirror image.
It's a mirror image of it. And in extreme cases, you can get what we call a tertiary, which is a third rainbow. Sometimes you can, theoretically, you can get it as many, oftentimes, but our eyes can't see really beyond the third.
Right, and kind of the other thing where the optics come in, that word optics, so we talked about how it reflects twice and you get a mirror image of the first one, so those colors are actually reversed. And actually, most common to us, anyway, is an arc across the sky. But if you were, say, up in an airplane or you could see beyond the horizon, that rainbow would actually make a full circle. But because of the land and the horizon, we only see the arc of it. But there have been a couple of pictures from airplanes where it's a full circle rainbow.
Yes, and it really is cool. And the other, just one more thing about rainbows. You rarely, if ever, will see one at midday because, as Craig said, you have to be, you have the sun, you, and the rain. Okay, if the sun is overhead, there's sun, you, and the ground.
Right.
Okay, there's no rain, there's no refraction. So you don't see rainbows at midday. You typically see them either late in the evening or early in the morning.
Right. So as we move onward here, we want to talk about other sky optics because sometimes they could look a little weird. How many of you have ever seen something like this? That is called, you get ready for this one.
Oh boy.
A circumzenithal arc.
Glad you said it.
There's also circumhorizontal arcs, but in this case, what that picture is showing is a circumzenithal arc, and it looks like a smiley face in the sky. That usually occurs above the sunshine because it's the same process that we just talked about. You have to have a certain type of cloud present for this to happen. Cirrus or cirrostratus clouds, and the sunlight is refracted through a hexagonal-shaped ice crystal. Now that's important because if it were a circumhorizontal arc, it wouldn't be a hexagon, it would be a plate-shaped ice crystal. So it really depends on the type and the shape of the ice crystal that sunlight is passing through. So that's an example of what we call a circumzenithal arc. Pretty rare, you don't see it too much, but every once in a while you will see kind of an upside down rainbow in the sky. So pretty cool there.
Very cool, indeed.
Let's see, next. So again, we were just kind of explaining that. So again, sunlight refracts and reflects, and it's literally the light will split into different colors as it bounces back to your eyes. And if you're curious, violet bends the most, and red bends the least, which is why you get the order that you do. All right, so next, Tom?
We have halos. Okay, now these are a little more common. You've probably seen these. Sometimes, they're called rainbows in the sky, which is technically not true because rainbows are caused by raindrops, while the circumzenithal, is that it? And halos are caused by refraction of light through ice crystals. So water in any form can bend can bend and refract light. And what's happening here, same basic thing as the arc, except now we have a full circle, and it's always in the center of the sun. So, and you notice it's always a perfect circle, and my geometry is escaping me, but there's a certain angle that it has to be in order for this to happen. And what you need to have that, what you need to make that happen, you want to have kind of a uniform coverage to the sky of the cirrus clouds. Like in this picture here, you can see the cirrus. There are no thick and thin layers. It's generally a uniform. It's transparent enough where it lets the light come through, but it's thick enough where you have enough water vapor, excuse me, see, ice crystals to help refract the light. And it makes, same thing, the red bends the least, the violet bends the most, so you still get the Roy G. Biv, okay, but in a circular motion around the sun.
Right, and this can also happen at night with the moon. Every once in a while you'll see a halo around the moon. And this is important if you're ever trying to make your own weather forecast. Going back 300 years ago, when there were halos around the sun or the moon, that would key in on farmers that, hey, the weather's going to get bad. There's usually a storm on the way because those high clouds filter out ahead of that storm, and then they create an optic like that. So again, these are, I believe, plate-shaped ice crystals, not the hexagonal ones that give you the kind of the upside-down rainbow. But these are more common than the circumzenithal arc. Actually, a couple weeks ago, I saw one of these. It was at night. It was with the moon. So it can happen at night too. But if you ever see a circle around the sun, a halo, that's usually a key that the weather's going to get unsettled as we head into the next 24 hours.
And that was one of the old, even as early as the 50s and 60s. That was one of the things that meteorologists learned. Was look for the, if you have usually if you have a good cloud chart and a good barometer, those two ways, you can become a pretty good amateur forecaster. Because if the halo's there and the barometer is falling, that's often an indicator again of some inclement weather usually within 24 to 48 hours, depending on the movement of the system.
All right, so as we go onward, this is something that we call cloud iridescence. Quite simply, it's not as defined as a rainbow. The colors are a little bit more washed out.
Right.
And there are tons of sky optics that happen. We're just going to go over a few of them here. But when you see something like this, maybe like a little, it's almost like a watercolor painting.
Yeah.
The colors
kind
of blend together in the sky. So there's not as much definition. But again, same idea. These are cirrus clouds. And when you see that kind of blob of color in the sky, that is referred to as cloud iridescence. So that's kind of the simple explanation
It is,
of that.
and you notice when you look at the picture, oftentimes, you'll see these usually mid-morning to mid-afternoon. That's when the sun is best. But you notice in this picture, unlike the halo where the clouds are kind of uniform here, you notice the density, it's a little more dense, a little whiter there. So the other cirrus clouds don't have enough crystals to really refract the light, but that thicker area of cirrus does. And it's normally right on the edge, like we have there, of the somewhat thicker cirrus clouds where we get that iridescence that you're talking about.
Now, the next one is one of my favorite ones. I've seen this before. And this actually is from a friend of mine from New York over the Finger Lakes, an actual picture that he snapped. And I remember this because it was a very cold winter morning. Now, you hear about sundogs a lot. Now, they are different from what we showed you before with the arcs and the halos and the cloud iridescence. Sundogs look like this. So this is also known as a 22-degree halo geometry.
There's a geometry.
Yes. Also mock or phantom suns. It actually looks like there are 3 suns in the sky. And what you're seeing there in this particular picture is over a vineyard in New York State. and it was one of those very cold winter mornings where it actually, the air almost had a sparkle to it because it was so cold
Sure.
that these little ice crystals were kind of suspended and drifting through the air. We call it diamond dust.
Right.
And the sun coming up aligned just right with those crystals to get a prism effect, and that's what we call a sundog. So you can see you can see the sun in the middle, and then what looks like two phantom suns coming up with it on either side of it. So that is a classic example of a sundog.
And it's a very good one, too. Typically, you have them with the cirrus deck that we had before, but this one, notice there, other than a few patchy clouds on the right side, that is, appears to me to be a clear morning.
Sure.
Like Craig said, my guess is probably what, 0, 10
Oh,
below perhaps?
it was below. It was
Okay,
below
so
zero,
it's
yeah.
below 0. When you get to that, -10, -15, yeah, you get these. You can literally see the sparkles, and they refract very well. This is a very dramatic picture. Usually you don't see sundogs that bright. But you notice they're always equidistant from the sun. The sun is still in the middle, and they're always on opposite sides. You can't have sundogs, at right angles. You can always draw a line from one sundog through the center of the sun to the other to keep the geometry correct.
That's right. So those are just some examples of different sky optics. Wish we could go into more, but we'll really quickly mention the northern lights, aurora borealis, and basically we were talking about the magnetic field of the Earth at the top of the show here. Basically what happens, and I don't mean to gross anybody out, but the sun burps, okay? And as that burp occurs, it sends out energy flying towards the Earth at hundreds of miles an hour.
Big time.
Yes. And basically that magnetic field around the Earth protects us from what could be very dangerous energy. So basically what happens is when that sun burps and that energy hits the magnetic field, here's Earth, you got the North Pole, the South Pole, it runs into the magnetic field, and that magnetic field is so strong that it actually sends the energy back and forth between the poles, and it bounces back and forth, and at the poles, that's where you get the northern lights. And they could be an awesome sight to see. I've never seen them, and I want to in the worst way, but they're really hard to see at this latitude.
Right, yeah, they're typically in the Arctic. I've only seen it once in my life.
Oh,
Because
lucky.
Unfortunately, we're cloudy, our winters, and they tend to be more easily seen in the wintertime. But we're so cloudy here in Erie that it's hard to get a clear night. And again, it only happens when that burp or solar flare comes up and hits the magnetic field.
Right.
And they're not as dramatic here.
No.
I mean, it was color, you could tell.
Right.
But boy, you get toward the Arctic Circle, North Pole, South Pole, bang.
And it sounds like a silly question, but I'll just answer it right now because I've had people ask me this question before, and there are no silly questions, right? The direction you want to look is north.
Yes.
So if we have a chance, point your eyes to the north. We, of course, monitor that here as well, and you can too. Great website called spaceweather.com. You can Google that, and there's all kinds of cool things about
Really,
space.
check it out.
Yeah, so what inspires you? That's our question to you, and hopefully you learned a little bit more about sky optics today. We want to hear from you, weather at WJETTV.com. Any science questions, any weather questions, send them our way. We would love to answer them.
We sure do, absolutely. And again, always looking for new topics. Don't hesitate, and we'd love to answer your questions. Okay, that is our Weather Academy for today. Hope you enjoyed it. Hope you learned a little something. The sky does so many cool things besides give us clouds, rain, and snow. Well, thank you very much, Craig. Once again, good stuff. Hopefully you enjoyed it as well. Thank you for joining us, and tune in Monday for another edition of the Weather Academy.
Have a great weekend.
Take care.